This is for Year 11 methods. We're going to look at question 13 from exercise 18E. So a rectangular block is such that the sides of the base are of length x centimeters and 3x centimeters. So we're going to draw a rectangular block. Okay, so we've got 3x, x, and we're not given the height, so we're just going to call the height h. Okay. We know that the length of all the edges adds up to 20 centimeters. So I'm going to add all the edges together. Now I know the h's take up 4 because I've got 4 edges of h. And the bottom edges will take up 8x, and the top edges will take up 8x. So we've got a total of 16x equals 20. When I rearrange this, we've got 4h equals 20 minus 16x. So h would equal 20 divided by 4 is 5, minus 16 divided by 4, which is 4x, sorry, 4x. So then we try to find the volume, which is length times width times height, which equals length times width is 3x times x, which is 3x squared. Height is given by the expression we just found, so 5 minus 4x. Expand it, we got 15x squared minus 12x cubed, okay? And we've shown what we required to show, so we're happy. Find the derivative. So that's part A. Part B, find the derivative. dv dx is given by 30x minus 36x squared, okay? So no dramas there. Find the local maximum for the graph between 0 and 1.25. Okay, so let's get an idea of what the original graph looks like. So if we got v and x, I can factorize this and get, if I take a factor of 3x out for v, 3x squared out, then we get 5x of just 5 minus 3 goes into 12 4 times, and we've got still got an x. Okay, so what's happening here is that this is going to be a negative cubic, so it's going to look like this. We've got a bounce at x, so we've got a bounce at x, and we've got a cut at 5 on 4. Okay, so we got a cut at not 5 on 4. We've got a cut at we got a cut at 5 on 4. So we've got something that looks like this. So 0, 5 on 4. Okay. So our first task is to find the maximum value. So the maximum value would be here, the local maximum. So let's use calculus or CAS calculator to help us with that endeavor. So we use the derivative. Just be really careful because it's quite easy to mistake in the derivative for the original. So this is the derivative. We let it equal to 0. So we're just trying to find where the stationary points are. Derivative and solve. Okay, just be careful not to differentiate this one because we've already done that. We know that at 0 we got a minimum, and 5 on 6 we got a maximum. Now 5 on 6 is before 5 on 4, which is great, okay, which is what we want. So we want to find what the coordinates of that are. So at 5 on 6, the original is given by 15x squared minus 12x cubed. I want to find the corresponding y value, so 12 minus 12x cubed. We want to find the corresponding y value, so just go given x equals 5 on 6, and you got 125 on 36. So local max is given by x equals 5 on 6, and our corresponding v value, v max, or v local max, would be at, let's go back to it, 125 on 36. Okay, so in terms of coordinate form, that's 516, 125, 136. Okay. Now, part D says that our domain's restricted to 0.8 now. So can you see our graph is now cut off? Okay, so we're no longer, if our graph's cut off, so let's say it's cut off here, it means that we need to check whether our maximum is still at what we want it to be. Our original maximum, local maximum, is at 5 on 6. Okay, so if we use a calculator, 5 on 6 as a decimal is 0.833333. Okay, now since our new domain is 0.8, which is less than 0.833333, we can't actually use so the new domain is actually here, so it's cut off here, so we can't use our original local maximum as the global maximum. We need to find what that equals to. So our new maximum will actually be the value at 0.8. So if I sub in 0.8 into the original, so I'll copy this, this will be my new maximum. So 0.8, and if I go standard, 0.8 and 432 and 125. 0.8, 132. 32 on 435. 125. 25. As we can see, since the graph is cut off here, I can't physically use the absolute maximum, the local maximum. So the new maximum now would be here. Okay. Now, if it says I'm between 0 and 1, we can use the original maximum, because between 0 and 1 would be cut off somewhere here now. The graph will be cut off somewhere here. So this is still going to be the maximum. So for part E, we're going to get an absolute maximum value of, so hang on, I should answer the question. The maximum V would be 132 or 125. I think it's 432, sorry. 432 or 125. And the maximum value of E would be back to the original, so 125 or 36. So hopefully that gives you an idea of how to deal with absolute maximums, because once you cut off part of a graph, that sort of changes possibly change your maximum value. So in part D it does, in part E it doesn't, because we look at the 0.5 on 6, part E says at 1, which is greater than 5 on 6, so we can include our original local maximum as the global maximum. So hopefully that gives you an idea of how to do this question.